Okay, now let's talk about voltage gain roll off at lower frequencies. Now, roll off is defined as what? The rate of decrease in the voltage gain with frequency is called roll off. Okay, and the next thing is for each 10 times reduction in frequency below Fc, there is a 20 dB reduction in voltage gain. So this is a general rule. Now the rule says that if you have a cutoff frequency, okay, now we know that if you have a frequency, okay, that goes beyond, that increases and goes beyond Fc, so basically this Xc is can be assumed as equal to 0. Okay, but if you have a frequency, when this frequency get decreases, okay, okay, further down the critical frequency, so they say that there is a 20 dB reduction in the voltage gain. So we can prove this somehow over here, which is given by this equation. So first of all, we what we can do, we assume this in formula, which is Xc equal to 1 divided by 2 pi Fc. So remember, this is the very known formula we know. Okay, now since we are studying low frequencies and we know the critical frequency Fc, so let's talk about if the frequency decreases, okay, the frequency decreases beyond this Fc, further down this Fc, so decrease in frequency. Okay, so let's take a value, certain values. If I say that if frequency it decreased by zero point 0.1, okay, by 10 times of the Fc, so let's suppose this is given, that if the frequency is decreased further by 10, okay, of the cutoff frequency, so I can get this relation. How? So I can put this equation, the value of the frequency in this equation. So if I put this, so I can say that 1 by 2 pi Fc, 2 pi, okay, F is 0.1, F is 0.1, okay, this is F, okay, and C we know. I will write C. Now 0.1 means 10, so 10 and 1.10, so I can write this as equal to 10 divided by 2 pi Fc, Fc. So I can write, now this is what, this is 1, this I can call this as equal to 10. Remember, this was Rn for a critical frequency, this was Rn, so that's why I can write this Xc is equal to 10 Rein, right? So it means that if I reduce a frequency, if I choose a frequency such that it is 1 by 10 of the critical frequency, so I would have what, this Xc for this case, okay, the Xc would be equal to 10 Rin, so this Xc would be equal to 10 Rin, okay, and this is you just worked it out. So if this is the case, so now I can what would happen to the voltage gain of this RC circuit? So again, remember this is attenuation, but we call this a gain, and if a gain is negative, so that's why we call it attenuation. So again the same thing we repeat, the voltage divide rule, Rn divided by the total the total resistance, okay, which is summation of Rin square plus the capacitance reactance, which is Xc square. Okay, now put the values Rin square as it is. Xc square would be what, okay, for this condition, for this case, remember, for we are talking about this case, right? So I can put the value of Xc is 10 Rin square, so this become 100, this is 101, okay, 101, and this would be 0.1. okay, so it means if I take the log and multiply by 20, because this is a voltage ratio, so it means that this is a value of minus 20 dBs. So the conclusion is that if your Fc, your frequency your operating frequency or the frequency of the signal, if it reduces, okay, to a lower value, okay, and by this we mean if it becomes, okay, 0.1 1 by 10 of the FC of the critical frequency, so the voltage, okay, there will be a further reduction in the voltage gain, and it will go down by minus 20 dBs. So the next point is that it means that if I, okay, in the next step, if I further reduce this, okay, so it means if I further reduce this equal to 0.01, okay, FC, so we can deduce that this voltage gain, okay, by the similar manner can be further reduced to minus 40 dBs, 40 dBs. Okay, now so this is just, the trend uh, of introduction in the voltage gain if the operating frequency decreases. So basically this is how since we are studying low frequency response, so that's why we want to calculate what should be the reduction in the voltage gain if frequency get decreases. So our threshold value is FC, and we keep decreasing the frequency. So in this slide we prove that for a frequency this reduction we get minus 20 dBs. Now let's slide. Okay, now this is a Bott plot. Okay, so this is a graph which readily explains everything in a very nice way. A Bott plot is what a 10 times change in frequency is called a decade. So basically a Bott plot is a plot between a decade of frequency and the voltage reduction in the voltage gain. So on the x-axis we can see we have different values of frequencies, but if I show you frequencies over here from the critical frequency, this is our reference frequency FC. Okay, so when it goes it increases the frequencies when it goes in increasing manner, so it increases by 10 times, 10 and 100. Similarly, if a frequency gets decreases, okay, from the FC reference point, reference critical frequency point, so it decreases by a decade, so 0.1 and then 0.01. So last time we proved that at the critical frequency, okay, the voltage gain is reduced by minus 3 dB. Mathematically we proved that minus 3 dBs. Okay, now and in the previous slide we just proved that if you further decrease the value of the frequency, okay, by 0.01 FC, so we get a decrease in 20 dBs. Okay, in the voltage gain, this is the voltage gain, remember this is AV, the voltage gain reduction occurs by 20 dBs. And similarly, if I further decrease the frequency by this amount, okay, so it means that I reached to a minus 40 dBs reduction. So let's thank you.